Okay, so last time we were talking about applications of trig functions, and we had done the whole trig of right triangle section, right, the SOHCAHTOA stuff. And so today is not an extension of that, but it's a further extension of applications of trig to future classes, basically. And we've kind of seen some of this stuff already. In fact, this first box here, this is all seen in previous sections, more than once, I'm pretty sure, as well. So, you know, remember, all this stuff is seen previously, and all of these follow directly from box number 1. So we don't, I mean, for one thing, I'll probably put this on a test anyway, or might put it on a test, but even if it's not on a test, you don't need to memorize them because they're from box number 1. Like, just for example, you know, why is it that cosecant equals 1 over sine? Well, that's because box number 1 tells us cosecant is 1 over y, and box number 1 also tells us that sine is y. And so if you kind of combine those two things, it becomes this identity. Right? So all these things just kind of follow directly from box number 1, if you remember that. Including the ones at the bottom. Right? These ones at the bottom are forms of x squared plus y squared equals 1. And these second ones don't come up too much. They come up occasionally, and we'll see them today. But the first one comes up a lot. It comes up a whole lot. We're going to see it multiple times today. It's very, very common. And it's very common because this thing relates sine and cosine. So if we want to relate sine and cosine, this is the one we use. This is the identity we would use. And it kind of has two sort of hidden identities involved in it. So if we want to write sine in terms of cosine, we can solve this equation for sine. And so that would become sine equals plus or minus square root of 1 minus cosine squared. Right, if I just get sine by itself, I would subtract cosine and take a square root, which ends up being this. And so I would write that down because that's another one we're going to use. We're going to use that immediately. And if we want to write cosine in terms of sine, it's very similar, except the two functions are switched. And so these three Pythagorean identities are the ones that come up the most, and these three are the ones that you really want to be familiar with. And so I like this stuff in the next couple pages, next probably 6 or 7 pages, all the identities, the entire identity section, because it's kind of a step back from the way math usually works. A lot of times in math it's like you get a set of equations or maybe a formula or some algorithm or something, and you just follow the steps and you get the answer. And a lot of what we've done is that. But in here, it's a little more, you have a little more creativity, it requires a little more creativity, and it can be borderline fun if you get into it. It can also be a little frustrating, I'll go ahead and admit that. But try to have some fun with it. Try not to get too frustrated. Instead, you know, use what we've learned, use your brain, enjoy using your brain in a new way. And we've already done a few of these, so let's remind ourselves how these work. So this problem, you know, we'll warm up with this stuff by writing cotangent in terms of sine, given that we're in quadrant 2. And I'm going to do it 2 separate ways, so you might want to write a little line down your page here, and we'll do it 2 ways, one on each one of those sides there. And so the idea is, remember, if you think back to when we first learned this, we want to look in the table of identities, and we want to find an identity that relates cotangent and sine, and try to write cotangent equals something with just sine in it, right? So the instructions here say, write cotangent equals, and then the other side should be something with sine in it, with just sine. And so when we're looking at the table here, there aren't too many ways we can relate sine or cotangent and sine, right? Like this has a cotangent in it, but no sine. And so this one is a good option because it has cotangent and it has sine in it. We just need to think about how to get rid of cosine, but that's a good start, right? It has both the things we want in it, and so we would start by writing cotangent of theta equals cosine over sine. And the goal here is, since we want something that just has sine, we want to get rid of the cosine, right? We want to change cosine into sine. So rewrite cosine in terms of sine. Because if we can do that, we'll have cotangent in terms of sine. And so one of the things we just wrote down is how we do that. Right? So if we look up here, I'm looking for something that has cosine in terms of sine, and I just sort of talked about how these identities are the ones that relate sines and cosines. So this one here specifically is cosine in terms of sine, and so we can use that one. So from above, we see that cosine is plus or minus square root of 1 minus sine squared from the Pythagorean identity. And we just need to pick plus or minus. All right, and remember, anytime you see some information about a quadrant, like quadrant 2, that's telling you something about the sign. And not sine as in sine and cosine, sine as in plus or minus. Right, and so since we're in quadrant 2, what does that mean about cosine? Is that positive, cosine positive or negative in quadrant 2?
Negative.
Good, yeah, cosine is the x value, which is negative in quadrant 2. All right, does everyone see that? That's right. Sometimes it's hard to read that in words, right? In quadrant 2, cosine, which is the x value, is negative. Right? That's what I'm trying to say there on that piece. And so that means we use the negative version of that. And so cosine is negative root 1 minus sine squared in quadrant 2 specifically. And so we can substitute this into what we just wrote. Right? You can plug this in, and then we'll have cotangent with just sine in it. So that would end up being cotangent equals minus root of 1 minus sine squared over sine. Right? So we met our goal because we rewrote cotangent in terms of sine. Now for a while at least, this doesn't have a ton of uses in like a pre-calc setting. The stuff that we're doing now has more uses in future classes, specifically calculus. And so I'll try to point out how that happens, but just know that there's not like a direct application of this stuff in this particular class. I'll kind of get you an idea of how it works, especially once we start looking at the next page. But you'll just have, most of all, what we're doing is practicing using trig. We're getting some good critical thinking questions, and we're kind of putting together a lot of the stuff we've been talking about into problems. That's kind of how it relates to here. And if you're going to take calculus, it relates very much to calculus, and I'll talk about how as we move forward here. Are there questions about that first one, though? How we did that? So a very common question I always get on these problems is, how did I know to pick this one? Right? Why didn't I pick this one, for example? And that's sort of something you'll have to confront on a lot of these problems, is which one of the things do you start with? Especially if there's more than one option. Right? Why didn't I start with this one? Right? There's cotangent again. And so one answer is, if we're trying to relate cotangent and sine, then this is one that has both of those in there. But just know that you can start with any of these things and get the right answer as long as you stick with it and do enough substitutions. And so I just want to show you a different way to do this one. Let's say we started with this one instead, this identity instead. And so let's look at an alternative method that will get the same answer, but just using different substitutions. So let's say we started with that Pythagorean identity that says 1 plus cotangent squared equals cosecant squared. We're trying to write cotangent in terms of sine, so we want something that says cotangent equals, right? So we would want to solve for cotangent. So we would start by subtracting the 1, right? And then we could take a square root to get cotangent by itself. Oops, I forgot to get rid of the square, right? It took a square root, and so it gets rid of the square. Sorry about that. And so this doesn't look particularly helpful right now, but at least we have cotangent by itself. And so in other words, if I can change cosecant into sine, then this would be what we wanted, because then we'd have cotangent on the left and we'd have sine on the right. And so one of the other substitutions at the top here lets us change cosecant into sine. Right? How do we change cosecant into sine up at the top? Thoughts? Cosecant equals what? This one right here? Yeah, so cosecant is 1 over sine, that very first one. And so we can change cosecant squared into 1 over sine squared. Right, so we can use that identity from above to write this as cotangent equals plus or minus 1 over sine squared. And just to be clear, from here to here, what I did was I wrote cosecant as 1 over sine. And we want to pick a plus or a minus, but that's the bulk of it, right? We have cotangent in terms of sine. Cotangent's on the left by itself. The only trig function on the right is sine. And so that we've achieved our goal just using a different approach. Let's go ahead and choose plus or minus first. So we're in quadrant 2, remember, and we know that cotangent is negative in quadrant 2. Right, so in quadrant 2, cotangent, which is 1 over, it's x over y, that's negative in quadrant 2. And so our final answer would be cotangent equals negative square root 1 over sine squared minus 1. So that's an alternative approach to getting us the same answer. And maybe those answers don't look the same, they kind of look different. But if you simplified this one on the right, like if you squared the terms, you'd get sine squared, and then if you subtracted it from 1, you'd find a common denominator, blah, blah, blah. If you simplified that fraction, you would get the same thing over here. And so they actually are the same. And so I'm just trying to point out, you don't always have to, there's not like one way to do these ones, which is what can make them fun. And some people think they're sort of easier that way because there's no like wrong way to start. There are easier and harder ways to start, but there's no wrong way to start these ones. Questions about the idea? Let me just say that, we're not seeing the uses of this, but it comes into play because perhaps it's easier to work with sines in your function than it is to work with cotangent. And so it depends on the particular problem. We're not really seeing those problems, but sometimes it might be helpful to change things into sines. You'll see that things get simplified a little bit on the next page. We're just kind of getting the introduction down here. Any questions so far? All right, so if we want to write secant in terms of sine, and we're in quadrant 1, we want to look for something in the top there that relates secant and sine. And so when I'm looking at the top here, there really isn't one of the things that relates secant and sine. I see secant here, but it has cosine on the other side, right? And secant really only comes up again right down here on that one. And so we're really kind of stuck with this one, but we know how to change cosine into sine, right? So we can start with this one, but then we can make this substitution, and then we'll have the answer we're looking for, right? Because we want to write secant in terms of sine. So what that would be then, we could start with secant equals 1 over cosine. And we know the Pythagorean identity that cosine is plus or minus square root of 1 minus sine squared. And so we can make that substitution directly into the cosine, and then we'll be done. But we should just pick plus or minus first. All right, so that's where the quadrant comes in. So we know we're in quadrant 1. Everything's positive in quadrant 1, right? X's and Y's are both positive there, so everything's positive. And so we know that cosine is positive in quadrant 1. And so we can make this substitution as plus 1 minus square root of sine squared. And so you can plug into here, and then we'll have secant in terms of sine. And so when we make that substitution, we'll have secant equals 1 over cosine, which is then 1 over square root of 1 minus sine squared, assuming we're in quadrant 1. So again, maybe it's more helpful to write things with signs, and if you're in a calculus problem and you've got a bunch of signs in there and then there's one random secant, maybe it helps to change things into signs. We're not really seeing those in this particular instance, But we'll see on the next page how things can certainly be simplified pretty nicely with this stuff. And we can get some pretty nice results that way. Can I answer any questions about that so far? Anything on this page? This is, we've seen some of the stuff like this. We did a couple examples like that previously, so we're kind of reintroducing that idea before we move into something slightly different. Anything? All right, great. So this is the real stuff that we're trying to get into. That was a good introduction into it. But trig identities, which is the rest of the section, is kind of the bulk of the important stuff that's related to future classes, again, specifically calculus. And so all the stuff in this box is just a collection of things that we've seen previously, right? So many of these things we saw previously. I don't mind telling you that the most important ones are the ones at the top. So these ones here are the most important ones. And so these get used the most often, and these ones have been seen previously. The ones at the bottom get used less often. These are used rarely, but worth putting up there. And so the ones at the top are just the ones from the last page, right? We saw those ones before. These Pythagorean identities were also on the last page. And then the even odd function ones, these ones were seen previously when we were talking about like the signs of the functions and things like that. We saw these ones here. And again, I'll go ahead and I'll probably put those on the test if and when you need them. And so the way that we use these is to simplify complicated expressions into less complicated expressions. And so the way we do that is by following these instructions. Rewriting the expression in terms of sine and cosine, and then simplify. All right, so that's always what we're thinking about doing, is we're thinking about rewriting in terms of sines and cosines and then simplifying. And you'll see when we do that, we're able to take something that looks really nasty and we'll simplify it down into something that's less nasty, or in some cases, nice. So I'm going to think about this first one, or the second one really, and then ask you to maybe think about the first one. But let me show you how it works. And let me explain the way that this is set up. And the next 6 or 7 pages, maybe more, are also set up similarly, where I've got like a table set up here, right? And so I'm going to write all my work down in the part that's labeled work, right? So all this stuff is going to go here. And then I'm going to justify everything I do with the substitutions on the right here. So the right-hand side is going to explain what's going on the left-hand side. And so let's start with this first one. So, it says change everything to sines and cosines. And so we've already got one cosine, so we don't mess around with the cosine, but secant and tangent can be changed. Right? We know that secant is 1 over cosine, and tangent is sine over cosine. And so we can make those two substitutions in this one to rewrite it with only sines and cosines. So this would become 1 over cosine minus cosine divided by sine over cosine. All right, so we've changed everything to sines and cosines, just like we were instructed. And then you'll see that things simplify into something nicer. And so this is a compound fraction, right? We've got a numerator divided by a fraction, and so it's a compound fraction. There are at least 3 ways we've talked about dealing with these things. Thoughts? What's one way we can handle this thing? Yeah, so we could flip the bottom one and multiply it by the top. That's one option. What's another option? Anything? What are you thinking about doing? Anne? Looks like you're thinking about something. Yeah, both the top and the bottom have a denominator of cosine, right? This has a cosine, that has a cosine, so we could multiply everything by cosine, and it would cancel out the denominators. That's another option. Third option? Anything? So the third thing we could do is try to add the top together first, right? We could find a common denominator on just the top, and then flip the bottom afterwards. So any one of those are good approaches. It really doesn't matter. Since the flipping thing was said first, let's do that. So we can take this and we can flip and multiply. This happens a lot in Trig, right? We've done that because there's a lot of fractions that are flying around. So we're always doing that in Trig. Anyway, when we flip and multiply, we get this. 1 over cosine minus cosine, and then we flip and multiply, so it becomes cosine over sine. Right, so you can see we took that and we flipped and we multiplied it. And so now it's not a compound fraction anymore, but now we just simplify. So this thing distributes and hits both terms. And so when we do that, we'd end up with 1 over cosine times cosine over sine minus cosine times cosine over sine. And you can see that in the first instance the cosines cancel, and so that's nice. And then in the second instance they multiply together to give us a square. So we'll have 1 over sine minus cosine squared over sine. I'm sorry, I forgot to do my justifications. I said it out loud, but I didn't write it in the right-hand side here. So let me just go back to the beginning. In the very first situation, I made the substitution that secant is 1 over cosine, and I made the substitution that tangent is sine over cosine. Sorry, I forgot to keep track of that stuff. So that's what gave me that first thing. Right. And then I flipped and multiplied. That's good. Now I've simplified things a little bit. And the nice thing is we've got a common denominator, right? We've got sine in the bottom in both of those things, so we can do that subtraction. So we can write this as 1 minus cosine squared over sine, which is getting simplified. Just pause there and let you catch up and see if there's anything you want to talk about first. Questions so far?
Can you reiterate when you distributed it?
Yeah, so I distribute this fraction to each one of those terms. So here it is multiplied by the 1 over cosine, and then those two things multiply to give you that. And then this is like a cosine over 1. And so here, those cancel because one's on the top and one's on the bottom. But here, they're both on the top, and so they become squared. Is that okay? And then we had a common denominator, so we just did 1 minus cosine squared on the top. Right, we didn't have to find a common denominator there because they were already common. Other things? So we can make another substitution. This is probably the first time we've seen it in this form, but this is a common thing at the top here. Does anyone see how this relates to one of the things at the top? I don't know if you see what I mean. Where is there a cosine squared? Let's say that. In the top identities, where is there a cosine squared? Yeah, right here, right? So anytime you see, and there's a 1 too, right? It's 1 minus cosine squared, and there's also a 1 in that. So anytime you see sine or cosine squared and a 1, it's this identity. This one comes up a lot, right? We've already seen it a couple times. So we can use that identity because we know sine squared plus cosine squared equals 1, right? And so that means that if you subtract cosine over, sine squared equals 1 minus cosine squared. And so you can make this substitution into the 1 minus cosine squared. Right, so this becomes sine squared over sine. And that's nice because it's like an x squared over x type thing, right? This is an exponent thing. And so we subtract the exponents, and so we get sine of 2 minus 1, which is sine. In other words, the other way to think about that is the sign on the bottom cancels with one of the signs on the top. So we just get sine. So I'll let you finish writing that down and ask any questions you have, but at least notice what we did. We started with this nasty fraction that had 3 trig functions in it, and just by knowing some substitutions in algebra, we simplified it down to just sine. Right? So if we had a calculus problem or some other problem in any class, doesn't matter what it is, if we had this in there, the original, we'd much rather replace it with just sine. Right, if you're trying to take the derivative of this thing on the top, it would be a real headache. But the derivative of sine is not that bad. Right, so this is what substitutions are always used in calculus. To start with something that's kind of complicated, simplify it into something that's easier to work with. Yeah. Questions? Questions on that worked? Any of the algebra there you want to talk about? Any of that stuff? Right? We're putting a lot of stuff together. We're distributing, right? We're using exponent ideas, compound fraction things. We're using a lot of the stuff that we've talked about previously in these kind of problems. Any questions at all? All right. Let's see here. How are we doing on time? We're slightly behind where I thought we'd be, so I was going to ask you to try this one, but maybe you can just help me work it out together. So let's simplify this thing down. And so, again, usually you want to change things into sines and cosines. And so when I look at the top of the page, I see that tangent is sine over cosine, and I see that cosecant is 1 over sine. And so I make those two substitutions. I make the substitutions that tangent is sine over cosine, and that cosecant is 1 over sine. So when you make those two substitutions, this becomes sine over cosine times 1 over sine. And that's nice, because similar situation as last time, where the cosines cancels. This time, this sine cancels that sine, right? You have sine divided by sine, so those two things cancel, and you just get 1 over cosine. So already that's nicer, right? We'd had two things, and now it's down to just one. But it's a fraction. We can make that even nicer. What's 1 over cosine?
Isn't that secant?
Yeah.
That is secant. Why not?
Because you want to get rid of all of those.
Oh, so changing the sines and cosines is just a good way to get the simplification started. But we do want to simplify as much as possible. So this ends up, so we know that secant is 1 over cosine. And so we can use that idea to change this into secant. Yeah, so good question. The question was, should we leave it like that because it's got a cosine? Why do we want to change it to that? I thought we wanted sines and cosines. Changing to sines and cosines is just a good way to get everything in the same terms. So you have only sines and cosines, and then you mess around with those, and then you can simplify it into something that's not a sine or a cosine, like this.
It's
Right.
not like cleaning up a food fight.
It's exactly like cleaning up a food fight. Yeah, that's usually how I explain it too. What do you mean by that?
I don't know, I just felt like a good connection.
Okay, if that helps, great. I'm glad that helps. Again, though, just notice a point here. Instead of having two trig functions, tangent times cosecant, it's just really just secant. Right? So if you've taken calculus, or if you're going to take calculus, if you're going to take the derivative of the first thing, it's like a product rule. But the derivative of the second thing is not. Right? So it simplifies down into something that's easier to work with. Questions at all? So this is one flavor of these questions, where we use some identities to simplify something down. And so this is another, so first of all, these identities at the top here, these are the most common ones. These are the ones that come up the most. But this is also an identity. Tangent times cosecant equals secant. That's an identity that's kind of like an obscure identity or like a hidden identity or something. And so lots of identities exist. And the next page is all about proving that some things are true. And so we're going to do the similar kind of thing, except instead of starting with something and just ending with something else random, we're kind of being told what we want to start and end with. And so we get a little more direction on the next page. Are there any questions before we look at the next page? Okay, great. So this is the good stuff. It's all good, but this is the stuff that we're really working towards. This is stuff that's very helpful in calculus. And so the general idea is we're trying to prove some identities. So like on this first one, we're trying to prove that cosine of minus x minus sine of minus x equals cosine plus sine. And so how do we prove that that's true? Well, we follow these steps, which let us do that. And so we always start with one side. So step number one is start with one side. And So you just start with one side, you write it down, and the idea is you want to transform it into the other side. And so the really important thing that you should remember is that you should always start with the more complicated side. So whichever side looks more complicated, you want to start with that side. So like on the last page, if we were trying to prove this identity here, this identity says this fraction equals sine. If we were trying to prove that that's true, we would do what we just did. We start with this, and then we transform it into sine. It would be really hard to start with sine and try to backtrack into this fraction, right? And so you always want to start with the more complicated thing and then simplify it into the less complicated thing. That's what number 1 says. Number 2 says, use the identities that we know, and the identities are the ones on the last page. That's what I mean. So you make some substitutions and you simplify. And it's really helpful to convert to sines and cosines. So usually the first thing I do, unless I see something else that's helpful, is I try to make sure that we convert to sines and cosines. And then I'm adding a 4th thing here. So I've got steps 1, steps 2, steps 3. Number 4 is like what happens if you get stuck. So I'm adding this 4th thing. You might want to put a 4 there just to note that it's part of the steps. A really helpful thing to do is if you get stuck, try to work backwards. In other words, start from the less complicated side and work back towards the more complicated. So I just told you not to do that, but what I'm saying is only do that if you get stuck. And I'll show you that as part of one of these examples. All right, so let's look at a couple of those. So if we want to show that this thing on the left equals that thing on the right, we want to start with the more complicated side. So the thing on the left looks more complicated to me, right? It's got minus signs in there. The thing on the right looks less complicated. And so we start by writing the more complicated side down. And then the idea is we do some substitutions, dot, 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 we'll do some stuff, and the last thing we write down should be the other side of the equation. Right? So we're going to start with the left, and we're going to transform it into the right by doing some substitutions. Right, that's the general idea. And so there's really only one thing we can do with these minus cosine and sine and minus x. We look at the first page, and this is what's telling us how to deal with things with a minus x in there. And so we can make those two substitutions. I know that cosine of minus x equals cosine of x from the first page, and the first page said that sine of minus x equals minus sine of x. And so when we make those two substitutions, you see that we get pretty much right to the answer. Right? So I make those substitutions like that, and then these two minus signs cancel into a plus. You got double minus, and so those two minus signs become that plus sign. And so we started with the left-hand side, and we transformed it into the right. Yeah?
So cosine negative x equals negative cosine x, or just cosine x?
Just cosine x.
Oh, okay.
That's because cosine is an even function, if you remember that back on that page, and sine's an odd function, and so that's what that means. Yeah. All right. So we started with the left-hand side, and we transformed it into the right-hand side. Questions? And that was, that's, I don't want to call it like super easy, but there was only one step, there was only one substitution, and it wasn't a whole lot going on there.
So you're not ever doing anything to the easier side, right?
Unless you get stuck. And so I'm not going to show you one on this page, but I can't remember what page it's on, but on one of the future pages, if you get stuck in the middle, sometimes it helps to start at the bottom and start working back up towards the top. On these first ones, they're not too bad, and so we won't need to do that, though. So, yeah, based on the question was, do we always start with the more complicated side, right? If we want to, on this next one, we want to add these two fractions together and get 1. And so we don't want to start with 1 and try to change it into those two fractions. I don't know how we'd start with that. But it makes more sense to start with the complicated side and try to add them together, and maybe it'll simplify into 1. Right? And so that's what we're trying to do on this particular one. So I'm going to change everything to sines and cosines. That's a good first step. And so secant in the bottom here, I know that secant is 1 over cosine, and cosecant is 1 over sine. And I know that from the last page, right? I'm just writing down these things here. I'm trying to change cosecant and secant into sines and cosines. And so we start with the left-hand side, because that's the more complicated side, right? And I'm going to change cosecant and secant into their corresponding things. Okay? Okay. Yeah?
So you're not going to change on the cosine and sine, and it's going to keep those the same?
Yes, we want to change everything into sines and cosines, so we just leave those things alone if they're already there. Right, so this becomes cosine over 1 over cosine. Oops, I didn't mean to write 1. It's cosine over 1 over cosine plus sine over 1 over sine. And so everything has a sine and a cosine. What do you do in this situation again when you divide by fractions? We've got two fractions doing some dividing. We flip and multiply them. So when we flip and multiply them, we get cosine times cosine plus sine times sine. Right? In other words, cosine squared and sine squared. And we want to eventually get down to 1. And this is what, the third or fourth time we've seen this one identity today. Anytime we see sine squareds or cosine squareds in an identity or in something that we're working with, we should be thinking about the Pythagorean identity. Right? So it begs us to use this one right here, which says that when you add the squares of those things, you get 1, and that's what we're looking for. And so based on that, we know that cosine squared plus sine squared equals 1. And so this thing just equals 1 from that. And that's it, right? We started with the more complicated side. We transformed it into 1. And so that proves that those fractions add together to give us the number 1. So, again, the general idea is we start with the more complicated side, and we want to transform it into the less complicated side. And so on this one, to me, I'd say the one that has 2 tangent squareds in it is a little more complicated, right? The other one has some squared trig functions, but there's a 1 in the numerator, and so I think if we change tangent to sines and cosines, we might be able to simplify it down into that thing on the right. Right, so the idea is we start with the more complicated side, we write that down, and we're going to try to make some substitutions that transform that thing into 1 over cosine squared minus sine squared. Right? So that's step number 1, starting with the more complicated side. Step number 2, use identities, and 3, change things to sines over cosine. So I know when I look at these identities that tangent is sine divided by cosine, and so we can make that substitution here and plug that in. And so remember the way this works here is I'm going to do my work over on the left, and then I'm going to write my substitutions down on the right here. So I'm explaining on the right that tangent sine over cosine, and then I'll make that substitution in that equation. But we don't have tangent, right? We have tangent squared. And so if tangent is sine over cosine, then if we square both sides of that, it becomes this. And so tangent squared is really sine squared over cosine squared. And so we're going to make that substitution on the left there, and we'll change tangent squared into sine squared over cosine squared. Right, so now we've done steps 1, 2, and 3, and now we just really want to simplify it down and see if we can get 1 over cosine squared minus sine squared. Right, so remember that's the goal, like dot, 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 somewhere down here below on the lower part of the page, the final thing we write down is going to be 1 over cosine squared minus sine squared. And we're going to connect them with equal signs. Okay, and so this is a compound fraction. We talked about how to simplify compound fractions last time. And to do that in this case, I'm just going to do the method that we talked about in class, which is to multiply by the common denominator. So for this here, what we want to do is we want to simplify the compound fraction. And the way I like to do that is by multiplying by the common denominator. If we just multiply everything by the common denominator, then all the denominators cancel, right? And so in this case, when I'm looking at the top and the bottom here, I see that they both have a cosine squared. And so the common denominator in the numerator and the denominator is cosine squared over cosine squared. And so if we multiply by cosine squared over itself, we don't change the equation, right? We don't change the problem, but we'll be able to cancel out all the denominators. And so let me do that right here. Make a little room for that. So I'm going to multiply by cosine squared over cosine squared because it'll cancel out all the denominators. All right, let me just remind you why we're able to do that. You're able to do that because cosine squared over cosine squared just equals 1. So you're just multiplying by 1, which isn't changing anything. But when you do this, the cosine squared in the numerator multiplies both the terms in the numerator, and so those two things will cancel. And then the cosine squared will multiply both terms in the denominator, and those two denominators will cancel as well. Right, so we'll end up canceling out the denominators, getting this following expression here. Right, so that's a nice way to simplify the compound fraction. Right, so we simplify the compound fraction just by multiplying by the denominator, the common denominator, I should say. So we're able to cancel out all the denominators. So a question I've been getting a lot about this one is, what happened here? So I multiplied by this, and this cosine squared canceled that cosine squared and left us with sine squared. And then it multiplied the 1 to give us this cosine squared. Right, so this times 1 gives us this, and then this times that 1 gives us this cosine squared. And remember, we're always, in the back of our head, the way we're thinking about these problems is we're always thinking about what is the final answer we're trying to get to. We're trying to get to this here, right? 1 over cosine squared minus sine squared. And now I've got that in the bottom. I've got cosine squared minus sine squared, so I've got the denominator that we want. Right? I just need to think about how to change the sine squared plus cosine squared into the number 1. If we can change the numerator here into 1, then we would have our answer. Right? So thinking about where you're going helps you reason through these problems and think about what substitutions to make, what do you have that's good, what do you have that you need to get rid of. And when I'm looking at this, the numerator needs to become a 1 and the denominator is all set. So how do I change that numerator into a 1? We've seen this one a bunch of times already. Any time we see a sine squared and or a cosine squared and the number 1, we think of the Pythagorean identity. All right, this one right here comes up a lot. It came up a bunch of times over the last couple pages. It's going to come up a bunch of times today as well. This one comes up a lot. That's one you really want to be familiar with. And so we know that, sine squared plus cosine squared equals 1. And so this is the Pythagorean identity. And so we can make this substitution. That just means the numerator turns into a 1. And we end up with exactly what we were looking for. So we check. I'm writing a check down because I started with the left-hand side. I made some substitutions and I transformed it into the right-hand side. And so that proved that identity. Questions? So on some of the last ones, I mentioned sometimes people get confused about how did I know, to change things to sines and cosines? How did I know what identities to pick? And so I'll just remind you one more time. It's a really good idea to change things to sines and cosines, right? It says it in step 3, and it's always a good thing to do. If you can't think of anything else to do, or you just want to always do that, that's a good thing to do. But we could potentially approach this one a different way. And I don't know if anyone was thinking about it. Was anyone thinking about making another substitution on our original piece here? Like if I put these identities up again, I don't know if we can get them all on the same page, but is there something about the numerator that we could change instead of sine over cosine? What are you looking at, Dwayne?
I was looking at the tan squared x plus 1 equals secant
Yeah.
squared x.
Yeah, so that's exactly what's in the numerator, right? Tan squared plus 1. So tan squared plus 1 is also secant squared. And so we could have made that substitution, and we could still end up getting to the correct answer if we use that one instead. Right, so I just want to show you that, just to show that there's more than one way to approach these problems. You don't have to follow some rigid rule. You don't have to be wondering, like, is this the right step? If you make correct substitutions and you do the algebra correctly, you can do these more than one way. And so let's just do that the other way. So let's use the fact that 1 plus tangent squared equals secant squared. Right? This is another Pythagorean identity. There's 3 of them. And so we could make that substitution and change the numerator to secant squared. And let's go ahead and change tangent to sine over cosine while we're at it. And so let's make both those substitutions and just see that we can get to the same answer doing a slightly different approach, right? So we just changed, instead of doing sines and cosines in the numerator, let's just say you saw that identity instead. Right, let me just point it out one more time. We're talking about this identity. Right, this identity lets us replace the numerator with secant squared, and we can still get the answer by doing it that way. And this is also a good time to review the other way to simplify compound fractions, because we have another compound fraction. And so the other way we talked about simplifying compound fractions, so multiplying by cosine squared would also work here, but we could also just kind of focus on the denominator and add those two things together. So if we found a common denominator here, we would change the 1 into cosine squared over cosine squared. Right, so this could become secant squared over cosine squared minus cosine squared. And that gives us a common denominator in the bottom. Right, now we have, both of them have a cosine squared down there. And so then we can do that subtraction. Right, we could do the subtraction and end up with this. Right? And so sorry, one sec. Talking about this now, this one here?
Yeah.
So I was trying to do this subtraction, but in order to do that subtraction we need a common denominator. And so the common denominator is cosine squared. And so I changed the 1 into cosine squared over cosine squared so that it has a common denominator. Other thoughts so far about that? This way slightly, it's a little bit more work going this way, but it's not that much more than the other way. Right, so now we can flip and multiply, right, because we've got a fraction on the bottom, so we can take this fraction and we can flip and multiply. And when we flip and multiply that thing, we end up with what we want in the denominator, right? So we'd end up with secant squared times cosine squared over cosine squared minus sine squared. And that's, you know, it's looking nasty at least, but the bottom's good because the bottom's what we want. This is what's in the denominator of the answer. And so we just need to figure out a way to rectify the secant squared and the cosine squared and get those things to sort of get rid of each other in some way. And so how do we use secant squared to get rid of cosine squared? Thoughts about that? Yeah, so secant is 1 over cosine, and so if secant squared is 1 over cosine squared. And so those two things cancel each other out directly because you can replace secant squared with 1 over cosine squared, and then they cancel each other right out. Right? So we'd have like 1 over cosine squared times cosine squared over cosine squared minus sine squared. Is it gross looking? Sure is. But those two cosines cancel each other out, and we get down to exactly what we were looking for. It was a little more work, maybe a couple more steps, but we can still get to the right answer, right? So it doesn't matter really exactly what substitution we make is what I'm trying to point out. It doesn't matter whether we change things to sines and cosines or whether we use this substitution instead, the Pythagorean identity. We can still prove it as long as we, keep up with everything, we do our algebra correctly, and kind of look towards the answer. Right? We're always thinking about, what am I trying to get? What's the answer? How am I going to get to that answer? It really helps guide you in those situations. Questions at all? All right. I would like you to give the next one a try. Really put yourself out there. I know this stuff can be a little confusing. That's okay. We're going to put ourselves out there and give it our best. And I want to help you get started on it a little bit, in case there's some confusion about how this one works. So we want to start with the more complicated side. Let me just get this one set up. If you feel good, you can go ahead and get started. But if you're like, oh, what do I do to start? Let me just get you started. So the more complicated side is the left-hand side, right? It's all the stuff on the left-hand side, and it's just sine on the right. So I hope you agree that the more complicated side is the left-hand side. And changing things to sines and cosines is going to be a good thing to do here. I think I would just recommend maybe foiling first to get started. It's not a big deal if you change the sines and cosines first, but foiling will just avoid having too many fractions before we need them. And so by foiling, I mean you do this thing, right? First, inner, outer, last, that kind of thing. And then when you foil, you get an expression. It's kind of a long expression. Let me write it farther over here. You get cotangent times cosine plus cotangent minus cosecant cosine minus cosecant. And so that's what you get when you FOIL it all out. And now is a good time to change things to sines and cosines. So now at this point, I would take cotangent and put in cosine over sine. And I would take cosecant and put in 1 over sine. And then a whole bunch of stuff will cancel. You can simplify, 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 right? Keep in mind where you're heading, minus sine. So when you get things with sine in it, that's a good sign. And when you get things that aren't sine, you should try to change them into sine. So anyway, let's spend a few minutes on that. Give it a go. Don't just sit there doing nothing. Let me help you. Talk to the people near you. Check with your neighbor. See what I have to say. Really give these a try. Right, you're going to have to do these yourself on Friday, so you should really start practicing them now. I'll give someone a hand with this right now. Does anyone need test topics too while I'm coming around? Got some test topics still. They're also on Blackboard, but we'll lost track of them and actually pass them out. Give someone a hand or pass out some topics. just going to write down the next step just in case you want to double check your work here. Get you a couple steps further, maybe double check your work. I'm happy to clarify if you want me to clarify something. Now at that point, some stuff cancels. You can keep on simplifying. You're going to need the Pythagorean identity. Just go ahead and tell you that. Sine squared plus cosine squared equals 1. That's going to come into play. Go straight. Alright, I'd like to start taking a look at this one. So we FOIL everything out. Looks like this. We change the sines and cosines. Right, and the reason we change the sines and cosines because it lets us compare apples to apples, right? We don't want to compare apples to oranges. We want everything to be on the same terms. And so when we put everything in sines and cosines, it makes it easier to compare. And things cancel and stuff, right? For example, from here to here, you'll end up with cosine over x minus cosine over sine minus cosine over sine. So those two things end up canceling out. And then in the other two, we're just left with those two terms. But the question is up to here. This is just substitution and then some algebra. I'm happy to clarify. Right, these things are over 1, cosines over 1, so those two multiply together to give you the squared. Right. These two multiply, the cosine multiplies the 1 to give you cosine. Sine times 1 gives you sine. Is that all right? Any algebra questions there? So now we've got two fractions. They both have a sign in the bottom. And so we can just subtract the fractions, right? They have a common denominator. So we can just make this cosine squared minus 1 over sine. So we just subtract the fractions. Okay. And this is where the Pythagorean identity comes in. It comes up a lot, right? If you haven't seen that already, realize that cosine squared plus sine squared equals 1. And so anytime you see a cosine squared or a sine squared and the number 1, it should make you think of this identity. All right, it's the one I boxed in last time, pointed out a lot. This one comes up quite a bit. And so what we have in the numerator is we have cosine squared minus 1. And so we can figure out what cosine squared minus 1 is by using this formula. Right? Because if we subtract 1 from both sides, we'll end up with cosine squared minus 1 on the left. And if I want to know what it equals, I move the sine squared to the other side. So we can kind of like rearrange this identity into one that tells us the answer here. So we can use this version of the Pythagorean identity and substitute it into the numerator. And remember, our final answer, we want to get minus sign. The last thing we want to write down is minus sign. And so this is making me feel good because I've already got a sign in there. This is going to put another sign in there. It adds a negative sign, right, et cetera, et cetera. You can kind of see how this is going to end up getting us to the answer. So this is a substitution that we would want to make. It's a version of the Pythagorean identity. And so then this becomes minus sine squared over sine. And so the 1 in the bottom cancels 1 in the top, right? And we get minus sine. Just to be clear about that, there's some confusion in my last class about this. Minus sine squared is like minus sine times minus sine times sine. And so it's like you have two of them in the numerator. One of them cancels, so this one might cancel that one, and then you're still left with the minus sign in the top. Right? Questions? Any questions at all? So I would call this like sort of a hidden identity. And I'm calling it that because on the next page, I'm going to introduce you to some other hidden identities. And so this is kind of like a hidden identity because it takes something we know, which is sine squared plus cosine squared equals 1, and rearranges it into some other form that's also true. And so I'm just going to show you a couple other hidden identities, quote unquote, on the next page that can be useful in certain situations, and we'll see them be useful in the next couple examples. But notice what happens here. If we take 1 minus sine and we multiply it by 1 plus sine, so we do this multiplication. If you multiplied that out, if you FOILed, if you did like this thing, if you multiplied all that out, you'd end up with 1 minus sine squared. And since this is true, sine squared plus cosine squared equals 1, 1 minus sine squared is kind of like what we just did in the last problem. 1 minus sine squared becomes cosine squared. And so that leads to this sort of hidden identity, and I would recommend boxing this in. If you multiply 1 minus sine times 1 plus sine, it simplifies into cosine squared. And so that's useful for a couple reasons. A, if you end up with something like 1 minus sine and 1 plus sine and they're multiplied, you automatically know how to simplify it. And this gives us something to do if we're stuck in a problem. So like just kind of looking ahead to the next problem. On this, if we're proving the next one, there's not too much you can do on the left-hand side of this, right? When you start with cosine over 1 minus sine, there's not much to do. But what we'll do is this. We'll multiply by 1 plus sine, which will get us moving. And so that identity is true for 1 plus sine and 1 minus sine. And there's a similar identity when we do it with cosine. So I'm going to box that one in too. I'd recommend you do the same. So here's another hidden identity. When you multiply 1 plus cosine and 1 minus cosine, it simplifies the sine squared. And there's similar ones with secant. Secant plus 1, secant minus 1. When you multiply those together, you get tangent squared. And then similarly with cosecant. When you multiply cosecant times itself, plus or minus 1, it simplifies to cotangent. And so, I mean, first of all, just notice that you can rearrange identities to get new ones, right? So that's the first thing I said here on the bottom. You can rearrange identities to get new ones. But what I'm really trying to say is, if you're given 1 plus or minus a trig function, then it's helpful to multiply by 1 plus or minus the trig function again. And so if you're given one plus or minus a trig function, you may have to multiply by the conjugate to move forward in proving the identity. If you haven't seen that word before, has anyone seen that word before? I feel like that's not the word doesn't come up a whole lot. A couple people have. So it's not like when I see that word, I think of Spanish. Or I think of conjugating verbs in Spanish. That's not what this means. It's the same word, but it means something different. And so in math, the conjugate of an expression a plus bx is just changing the sign between them. So the conjugate of a plus bx is a minus bx. So you just change the sign between them. And the conjugate of a minus bx is a plus bx. So that's just something you may see, especially if you're going to go on and take future classes, like that comes up in calculus and things like that. Conjugate just means you change the sign that's between the terms. Notice that a is always positive in all those cases. We don't change the sign of a, you just change the sign of what's between them. And so again, on this next one, we'll do that to start this one off. That's a good thing to do, starting that one off. And we'll also see that in this example here. So let's say we wanted to prove that 1 over 1 minus sine minus 1 over 1 plus sine equals 2 secant tangent. If we were going to prove that, we might start out with the more complicated side, which to me is the one that has a couple fractions in it. And so we would write down the more complicated side. And there's really only one option of what we can do here. Right, the instructions say change everything to sine and cosines. Well, everything is a sine or a cosine. We've got a couple signs in there. And so the only really thing we can do is try to subtract those two fractions. Right, we've got two fractions, different denominators, and so we should try to subtract them, which is going to involve finding the common denominator. The common denominator of these two expressions is just what you get when you multiply them together, right? And so the common denominator is 1 minus sine times 1 plus sine. And we know from above this equals cosine squared. Right, it's one of the hidden identities. So when we find the common denominator, we'll multiply these two things together and we'll end up getting cosine squared. So it gives us sort of a head start in how to simplify that thing. Right, so when we find the common denominator, it would look like this. Right, we take the fraction on the left and we give it the denominator of the one on the right. So we multiply by 1 plus sine over 1 plus sine. So that'll give us that common denominator there. And then we do the same thing with the other term, except we use the other denominator. So multiply by 1 minus sine over 1 minus sine. Right, and again, we already know that the denominator is going to equal cosine squared. We don't need to mess around with the denominator. We just sort of proved it up top that that's going to simplify down to cosine squared. And so we can just like jump right to that and just rewrite that as a cosine squared in the bottom. Right, so we'd have like 1 plus sine over cosine squared minus 1 minus sine over cosine squared. Right, let me pause there. Let you think about that for a second. Right, all we did was try to find the common denominator, and then we used the fact that we know when we multiply those things together, we get cosine squared. That's what we've done so far. Questions? Algebra-wise or other? I'd love to hear some more questions. I know this stuff is, I don't know, can be complicated. Some people feel daunting. It's like a daunting kind of thing. There's a lot of stuff going on. We're relating trig functions. We're using the identities. There's fractions. There's algebra. There's a lot of stuff. So I'd really like to answer a question if you have it. Something's not clear about where something's coming from.
So by multiplying the 1 plus sine squared plus...
These two?
No,
These two.
yeah.
Yes.
You automatically get cosine squared.
Yeah, so what I was saying up here is when you multiply those things together, you get 1 minus sine squared, and because of this identity, you can change that into cosine squared. So these tell you sort of what to jump right to. If you multiply those things together, it tells you to jump right to this instead. I mean, we could multiply it out and do a couple more steps, but we'd eventually get cosine squared anyway, and so that's just one that we're trying to treat as its own identity. Other thoughts or questions? Thank you for that question. Say it.
So basically you multiply each side by common denominator on both sides, right?
Yeah, so I took this one, which is right here, and I gave it this denominator by multiplying by a form of 1, right? This just equals 1, so it doesn't change it, but we get that common denominator. And then I took this term, which is right here, and multiplied it by this denominator, right here. Again, this equals 1, so it doesn't change anything, but we end up with the same denominator when we do that. And then I just simplified those denominators into cosine squared because I just know from above that they're going to end up equaling that. What else? All right, so now we can do the subtraction, right? We have a common denominator, so we can subtract the fractions, but we need to be careful here. This minus sign is subtracting both of these things, so in other words, it distributes. It makes this one negative, and it makes this one positive. Right, so when we do that, the fraction ends up looking like this. We get 1 plus sine x minus 1 plus sine x. Right? That negative sign switches both those things around. It makes the 1 negative and the minus sign positive. And that's important because otherwise things won't cancel and we won't get what we want, right? So in other words, like we get plus 1 and minus 1, so those go away. And then we get sine plus sine, which is 2 sine. Is that part of it? So remember, we're always trying to think like, what are we headed towards? What's the final answer? Are we on the right track? The final answer that we want is 2 secant tangent. And so, I don't know, this doesn't make me feel super good about it. Maybe it's not obvious how this becomes 2 secant tangent, I don't know. But it's got a 2, and there's a 2 in the answer, and so that alone is making me feel like it's okay. Right? We at least have part of the answer in the 2. And so this is usually where I like to emphasize step 4. So we've talked about step 1 through 3, right? Start with the more complicated side, use identities, change the sines and cosines. We haven't done step 4 yet, and that was the step I added at the end of these, which is if you get stuck, it's helpful to try working backwards. In other words, start from the other side and work back towards the side you've been doing. And so let's just look at what that looks like here. So let's say we're stuck here. I don't know if we're stuck. Maybe you have an idea, but let's just pretend, even if you have an idea, that we don't. We know that the very last thing we want to write down here is 2 secant tangent. And so I know that I want to, what we have, 2 sine over cosine squared. I eventually want to be able to write down 2 secant tangent. And so we can start with what we want and work back towards this and try to like meet in the middle. So it's a really good technique if you get stuck. Do you see what I'm saying there about that general idea? It's really, really helpful. If you get stuck, we know we want this to eventually be this. And so start with what we want and try to meet them in the middle somewhere, right? So if we can make this look like this, that would be good. And so we can start at the end and change things to sines and cosines and try to meet in the middle. So I know that like secant is 1 over cosine. And I know that tangent is sine over cosine, right? And as soon as you write something like that down, sometimes that's enough to kind of like be like, oh, I see how this is going to work. And if not, that's okay. Just like take it one step at a time and try to get to that eventually. Right, so when I make those substitutions, so let me make that note first, in case it's not clear what we're doing here. So if you get stuck, try to work backwards. Let's pretend that we're stuck. If stuck, try working backwards. So instead of trying to go forward with this, try to start with what we want and work back towards that thing. So let's make these 2 substitutions. Secant is 1 over cosine, so this becomes 2 times 1 over cosine. Tangent is sine over cosine, so this is sine over cosine. And you can see we're almost like directly getting what we're looking for. Because now we can multiply all these things together, and it would be what we're looking for, right? Just to be clear, this is a 2 over 1. So when I multiply this, I multiply 2 times 1 times sine. So that's 2 sine in the numerator. And then in the denominator, I multiply 1 times cosine, which is cosine squared. And that's exactly what we were trying to match up with. Right? They match. So if you get stuck, it can be really helpful to go down to the end where we want to be and try to like work back towards the middle and connect them in the middle there. Questions at all? Anything? Yeah.
So, can you just make, like, for the 1 plus sine x minus 1 plus sine x?
Yep.
Can you just, like, leave the two signs there, and then for the cosine, you would just split it between cosine x times cosine x, and then I would just,
So you're talking about at this point?
yeah, at that point,
So like break this up into two separate things? Is that what you mean?
yeah, like, leave those two signs there, but split the cosine power 2x, and then just make one tangent, and then just make the other one secant, put the two still there.
So I think, and this is a good question because it's going to apply to the next problem. Are you talking about doing this? Well, first of all, they're being multiplied, right? They're not being added, I'm sorry. Are they being added? Oh, they are being added. So you're talking about making that like sine over cosine squared plus sine over cosine squared. Is that what you're thinking?
Would it just be cosine, not cosine squared, or it has to be cosine?
It has to be cosine squared. Yeah. So I think that's why that one won't work too well. The way so that's not, I mean, that's true, but that's not going to help us. The way that you could keep going with that first one is you go from this, that equals 2 times sine over cosine times 1 over cosine. You can break it up like that, and now this becomes tangent, and this becomes secant. That's how you could kind of keep going forward with that
Yeah,
method.
that's why I meant, like, splitting the cosine into two cosines.
Ah, I see what you're saying. Yeah, so you would want to do that not at this point, though, when they're being added. You would do it at this point, after they've been added. Yes. Yep. Yeah, so that's a good point. Like, and you know, it speaks to what I said before. You don't have to do it the way that I'm doing it. I'm trying to show you the way, you know, I'm trying to give you my thought process and help you sort of build that intuition. But yeah, if you saw that, then that would be a completely legitimate way to move forward with it as well. Other questions? All right, we're going to spend the rest of the time giving that last one a go. I'd like you to try this last one. Again, I'm happy to get you set up with it if you need some help getting started. But please take advantage of this opportunity to try one while I'm here and while you can get that correction. And so to start this one, it's not obvious to me which is the more complicated side. And quite frankly, you could start with either side. And so I'll show that both ways. You can decide which side you want to start with. You can either start with the left-hand side and try to work towards the right, or I'll show you the other way, which would be starting with the left-hand side, or the right-hand side, and working back towards the left. So pick one and go with it. That's fine. Let's just talk about how to start each one. How would you start one like this, right? Everything's in terms of sines and cosines, so we can't like change things to sines and cosines. It's already done. What's a good thing to start on that one based on what we just talked about on the last page? Got 1 minus sine in the bottom. So what would be a good thing to do? We could multiply by, yeah, the conjugate, right? We just figured out that when you multiply those two things together, it can help sometimes. And so on this one, I would recommend starting by multiplying by the conjugate over the conjugate. And so that would be taking this one and multiplying by 1 plus sine over 1 plus sine. And so you would think about that. On the next one, and then we know what the bottom multiplies out to, etc. If you wanted to start with the second one instead, you might want to change things to sines and cosines, but you're not going to be able to avoid multiplying by the conjugate on this one. Even if you do this bottom one by making these sine and cosine substitutions, you're still going to eventually need to multiply by the conjugate at one step. So I'm happy to show you that if and when you get there. I would just choose whichever one of those approaches looks more appealing. Excuse me. And see what you can do with it. You'll also use this concept in this top one as well. You're going to use this idea where you break up fractions into two separate pieces. I thought I'd just mention that since you will involve, this one here will involve that step. Alright, I'd like to spend at least 10 minutes on this, maybe more. So please, I'm not going to let you get out of this one. Give it a go. Spend some time on it. Ask the people around you some questions. Let me help you. Really give this one a go. I really do want to help, so let me help you get started if you're stuck. Yeah, so that's, now we need to multiply by 1 minus sine, or 1 minus sine. Yes. To help someone else get started, check what we're thinking, those kinds of things. So this is a very common mistake that people do. What we're trying to do is start with one side and transform it into the other side. Not write down both sides, show it makes sense. You know what I'm saying? So this is an okay approach. Imagine this side over here. That's what you want to do. That's true, except that's not true. Cosine multiplies the sine, so this is sine. And then you can cancel that out with both of those. You can cancel just one. Times 1 plus sine. So this multiplies into 1 and the sine. Cosine times 1 is that. Cosine times 1 is that. Yeah. So it's kind of like, that's what I wrote down, the 8 plus b. I'm going to break it up like this. Usually we talk about adding common denominator. We want to start with this. Now, that's why it's going to be one more select. That way we're one more select. Cosine, sine, cosine, this. That was awesome. Because on the last page, what I was trying to show you here was when you multiply by 1 plus and 1 minus, it simplifies it into cosine squared. So we know that when you do that,
big orange
bottom
ball
also
with
becomes
blue 76 and
squared, which is helpful.
That's the iconic symbol of our 76 gas stations. We're new in the neck of the woods, but have been on the driver's side for a really long time. Providing top-tier gas and ways to make driving fun and easy. Come check us out. Our gas stations
so-
are fuel up and recharge.
So these two things cancel into cosine squared.
Takes you.
Oh,
76. We're on the driver's side.
part of it.
Right.
And that removes these, so that removes them. This one cancels, right?
Yep.
So we're left with that.
So is this is those two?
Yeah, this is,
Then where's this cosine?
I broke it apart. I made that one line, then I made that one line.
But this is one term. So first of all, it should be a plus. And then this term is sine, cosine.
Okay, I broke this up and that plus that, made cosine 2. And then I
Oh.
put the sine over the cosine, because I broke them up.
I see what you're saying.
So this,
So-
this would be,
You can't add these two things together because that's one term. And you would only get square if they were multiplied. So what I'm suggesting we do here is we break it up into this fraction plus this fraction.
okay. Well,
Yes, that's why I was like, oh, that looks right, but it was no.
so then this would be, no, that wasn't it.
No, right.
That wasn't it.
Just
So then I really
cosine.
can't get rid of that one.
So this is
Yeah.
not a square.
So that one I think is- But this one has a square.
Right.
And then this is. But it still remains.
Yes, it still needs a sign. Yep. Right. And now some things cancel, right? This will cancel one of them.
Yeah. Then if they were, cancels one of them.
Right.
So it gives me that down here.
Right, so then you get one over cosine,
Yeah.
sine over cosine.
Once you go past, right?
So you're kind of going backwards and you're meeting in the middle.
Yeah, that's what I was kind of trying to do.
Yeah.
Okay, so that's. Look worse than.
Don't they always? All right, let's take a look at this one. So if you wanted to start with the left-hand side, you would do this, right? And then the bottom, we know that the bottom multiplies out and will give us cosine squared. That was the hidden identity from the last page. And then the top, well, there's a bunch of ways to think about it. I guess I'll just leave it not factored. If I leave it not factored, then that's nice because I want to cancel out a cosine, right? It'll let me cancel one of those. And so like one of those cancels that. And we would get 1 plus sine over cosine. Is that all right so far? And so remember, if we're just trying to think about what we want, what we're heading towards, we want a secant plus a tangent. And notice that both of those things have a cosine in the denominator. And I now have a cosine in the denominator. So we're on the right track, in other words, right? And so the way we want to think about this now, if we're kind of moving forward, is I don't want a fraction in my answer. My answer isn't a fraction. It's two things being added. And it's also two things being added, right? So we want to have two separate things, not one thing. And so that's what leads me to this property. Usually we think about having a common denominator like this and then adding the fraction to get this, right? But we can go the other way too. We can start with a fraction that has a common denominator with things being added and break it up into two separate things as well. And so we can make this into 1 over cosine plus sine over cosine using that idea, right? Using that idea. And now, 1 over cosine I know is secant. And I know that tangent is sine over cosine. And so we get right to the answer because here's my secant and here's my tangent. Questions? Now might be a good time to talk about what the test looked like too. So on the test, let me actually wait until I turn this video off. I don't want this to be on record. Because I'll change it in the future and I want to use this video for all of time. So let me hold your horses on the test for a second. And let's just do it this other way first. Other questions about that way first? All right, so let's say we started with this way instead, the right-hand side. We change things to sines and cosines, and we're basically going to go backwards in the way we just did, although it does look slightly different. So we get that, right, using those substitutions. We have the same denominator, so we can go ahead and just add the fraction. Right, so I just added the fraction. And now at this point, there's nothing we can do, just the similar way at this point there was nothing we can do, except multiply by the conjugate. The only thing we can do at that point is multiply by 1 minus sine over 1 minus sine. And so we could take what we had there and use the information from the last page by multiplying by the conjugate over the conjugate. Right, when we do that, it helps us realize that the numerator becomes cosine squared. So let me just be clear here. This is multiplying by the conjugate over the conjugate. And the numerator we know will simplify into cosine squared. And the denominator we leave alone. And so how did I know not to FOIL that denominator out? Well, the final answer we're looking for has a 1 minus sign in it. And so here's my 1 minus sign. I don't want to mess that up, so just leave that alone because I want that in the final answer. Right? Again, we're trying to think about where we're headed, and it helps us make decisions. In other words, I want that in the denominator, so let's get rid of that by canceling with 1 at the top. And so we get cosine over 1 minus sine, which is what we were looking for.